sodium borohydride. Which one here? The sodium borohydride. You have to calculate the oxidation number of boron. Okay. So in this one, you can take that one, sodium plus boron plus 4 into hydrogens is equal to 0. Okay. But in this one, generally hydrogen can show +1 oxidation state. But in this one, hydrogen is linked up with the boron metal and as well as the sodium metal. Already I given the information. Whenever hydrogen link up with the metals, in that situation, hydrogen can show here the -1 oxidation state. Okay. Sodium belongs to first group element. So you can write here the +1. In the place of boron, you can write X plus 4 into, here for hydrogen I am taking which oxidation state? -1. Due to the reason here the hydrogen is linked up with the two metals. So you can write 1 plus x minus 4 is equal to 0. X minus 3 is equal to 0. So x is equal to how much here? The 3. Okay. And one more important compound, potassium iodide. What it is here? The potassium iodide. In this one, you have to calculate the oxidation number of potassium. Okay. So generally, all the people think that one K plus 3 into I is equal to 0 is nothing but K. K should be represented with the hex plus 3 into -1 is equal to 0. So x minus 3 is equal to 0. X is equal to 3. Okay. But it is the wrong process. It is the wrong process. Why? Because potassium belongs to which group element here? The first group element. Always the first group elements can show here the +1 oxidation state. But in this compound it can show what it is +3. Is it possible for the potassium? No. Are you understand? So that's why in this one you can write this compound like Ki plus I2. Okay. What you can write the Ki3 compound should be here the potassium iodide plus iodine. So normally it is the elements are generally possess what is the oxidation state? 0. So in that situation you have to calculate for which one here? The in this compound only potassium. So then what is our oxidation number here? K plus I is equal to 0. X for iodine shows here the -1. So now X is equal to what is the oxidation number here? The +3. So +1. Okay. Are you understand? So it is the wrong one, it is the right one. Next of all, one more exceptional compound. It is nothing but Carous acid. What is the formula of Carous acid? H2SO5. What it is here? H2SO5. So for this one, I am taking that one. So it is the important compound. In this one, you have to calculate the oxidation number of sulfur. So before the calculation of the sulfur oxidation number in this compound, you can write the structure of that acid. So here generally sulfur, okay, S double bond O, S double bond O, and here the O, O, H, and it is our OH. Okay, but generally people are think that one all the 5 oxygens are belongs to here the -2 oxygen. Okay, -2 oxidation number. But in this one, here it is the normal oxygen, it is also normal oxygen, it is also normal oxygen. But these 2 oxygen atoms are not normal. Why? Because both are present here like the peroxide. Which one here? The peroxide. Already I given that one. For peroxide, oxidation number here the -1. Which one here? The -1. Generally -2. Okay. But here the oxygen atoms are formed which bond? Peroxide bond. In the peroxide bond, each oxygen atom shows here the -1 oxidation number. For this one -1 and for this one also -1. Okay. Remaining it is also the -2. Remaining it is also the -2. Remaining it is also -2. So what will be here the sulfur's oxidation number? So for that one, I want to give here. Okay. So you can write 2 into hydrogens plus 1 sulfur plus 3 into normal oxides. Okay. Next of all, 2 into peroxides is equal to how much here? The 0. Is equal to how much? 0. So now for this one you can write 2 plus 1. Sulfur can show here the X. For normal oxygens -2 For this one here, the minus 1, 0. So now 2 plus x plus 6. So minus 2 is equal to here the 0. So from this one, 2 plus x minus is equal to 0. So x minus 6 is equal to 0. X is equal to, what is the oxidation number here? The plus 6. It is the right answer. How can I say it is the right answer? Why? Because sulfur always belongs to which group element? Sixth group element. Sixth group element's common oxidation number is here the plus 6. Okay. So it is the information about the Carus acid. What is the formula of this one here? H2SO5. Okay. Like these kind of the exceptional compounds are there. Okay, so especially it is the very important for the 2 marks question. It is also the important for the 2 marks question. It is also important for the 2 marks question.